What's up, everybody? In this problem we are asked 3 questions, and this is regards to multivariate problems. And the way to solve these problems, and one first thing to notice is where you have the y and where you have the x, because sometimes they change this around. So the logic is always the top part like this. So if you are asked to find marginal probabilities, you just pretty much sum all these up. So the top part comes down, so you sum all these up. So you'd have a number here. And the same thing for this one. And when it's the other one, it's like this. So I usually draw this so I don't make any mistakes. So this part, the marginal parts, you'll end up finding those here, okay? So it doesn't matter if they call this Y, Charlie, Adam, it doesn't matter. So it's always the top part comes down and the left part goes to the right. That's it. So let me just clear this out. Okay, so in order to find the values, you are asked to find the values that alpha can take. And in order to solve a problem like that, it's important to notice that when you sum all these up, so this one, this one, this one, and this one, it will equal to 1. But if you do that, if you sum all these up in equal to 1, everything will cancel out and you'll get 1 equals 1. And it's understandable because look at it. You have 3 alphas, you have minus 3 alpha, so these 3 cancel out, and then you are left off with 1 equals 1. So the way to solve this is to understand that any probability has essentially comes within 2 values, 1 and 0. So this is the first part. You know that any probability, doesn't matter if it's a multivariate or univariate, it always is between 0 and 1. So 0% and 1% and 100%. In this specific case, when you're talking about a parameter, what you do here is take the one that has like more stuff in it, so these ones are equal. So you take this one and equal it to 0. So what you do is 1 minus 3 alpha equals to 0, and you take this one to this side, it's 1 equals 3 alpha, and then you take this one to the other side, dividing it, so you're left off with alpha is equal to 1/3. And this is the first part. So when you understand this, essentially you are left off with 2 values. So alpha would be also between 0 and the top value 1/3. So you write it like this. Alpha is in between 0 and 1/3. So this is your answer for the values that alpha can take. The second problem, they tell you 3 things. The first one is that alpha is equal to 1/6. U is, you have this expression, it's a modulo of x minus y divided by 2, and then you have this expression for v. And you are asked to find the mean for u and the mean for v. So how do you solve this? Well, the first thing is, if they're already telling you that alpha is equal to 1/6, you can actually go there directly to the table and put that values in. So we have y equals 0, y equals 1, x equals 0, x equals 1, then is 1 minus 3, 1/6, then 1/6, 1/6, and 1/6. And this one, let's do the math here real quick. So you have 1 is the same thing as having 6 over 6 minus 3/6. So this is essentially 3/6 or 1/2. So just to simplify this a bit, let's get rid of this part and just write down 1/2 there. So these are the values when you are told that alpha is equal to 1/6. You just plain out distribute the values, find the values that are corresponding to the entries, and just substitute these ones directly in a table. Okay, so this is the first step. The second step is finding the expected values, and you are told that u equals this expression and v equals to this expression. So what we do in cases like this, essentially you do a second table, it's x and y, and then all the values that x and y can hold. So essentially it's 0, 0, 0, 1, and then 1, 0, and 1, 1. These are all the values between x and y. And then what you do essentially is use the expression u to find out what happens between x and y. A good example would be, let's say we're looking at this expression. Let me just put this here to make it easier. So x minus y divided by 2. What's 0 minus 0 divided by 2? It's 0, right? So that's exactly what we're doing here. And for the other expression, v, we have x plus y minus xy divided by 3. So 0 plus 0 is 0, minus 0 times 0 is 0, divided by 3 is 0. And if you do the other ones, you'll find that the values are as follows. It's 1/2, then 1/2, then 0. And these three are 1/3, 1/3, and 1/3. So now we have a table, a second table, that is telling us all the possible combinations with these two formulas. This is the second part. The third part to solving this problem is finding out for each one. And what I mean by this is, when you look at the u function, it varies between 0 and 1/2. So we are saying here essentially that u varies between 1 and 1/2. In order to find these values, now we need to correspond the tables that we have. So we have this table and we have this table. So when x equals 0 and y equals 0, so this is the case that we have here, we have one value there, which is 1/2. Let me get this on this side. And we also have u equals 0 when x equals 1 and y equals 1. So it's this one here. So essentially, to find the value that we'll get here, it's 1/2, so this one, plus this one, so plus 1/6. And make some adjustments here, so this times 3, this times 3, so you have 3/6 plus 1/6, so that's 4/6, same thing as 2/3. So this one is 2/3. And for this one, we're going to do the same. So we have two entries here that corresponds to the value of 1/2. It's the first one when x equals 0 and y equals 1. So it's this one, x equals 0, y equals 1. So it's 1/6. And now we have a second one when x equals 1 and y equals 0. So x equals 1, it's this one, and y equals 0. So it's another 1/6. So it's 2/6. Or if you simplify the expression, we get 1/3. So this is the value for the corresponding entry. Just get this out of the way. And for the other one, we're going to do the same. So the value of v varies between 0 and 1/3, as you can see here. So varies between 0 and 1/3. And now we need to find the corresponding value of the function, so f of v. And you'll find here essentially that when v equals 0, so when is v equals 0? There's only one entry here, which is when x equals 0 and y equals 0. So when that's the case, so x equals 0 and y equals 0, it's 1/2. So we can get this one directly here. And the other one is when v equals 1/3. And we have three entries here. The first one is when x equals 0 and y equals 1. So this one and y equals 1, so that's 1/6. Let me get the math here. The other one is when x equals 1 and y equals 0. So x equals 1, it's this one, and y equals 0, it's plus 1/6 again. And the last one is when both are equal to 1. So y1, x1 is 1/6. So 3/6, same as 1/2. So we have 1/2 here. So the expected value, as you remember, it's this one times this one plus this one times this one. So the expected value of u is equal to 0, because 0 times something is 0, plus 1/2 times 1/6. So it's 1/6. This is the expected value of E of u. And the expected value of V, same thing, so 0 times 1/2 is 0, plus 1/3 times 1/2. So in the specific case, it's 1/6. To solve this last problem, we need to use both tables again. There is this property that says that two variables are independent. This happens. So the probability of A and B is equal to the probability of A times the probability of B. In our specific case, we are using U and V, but this is the same thing. So essentially what we can do is as follows. So let's say the probability of X equals 0 and Y equals 0. So we find this entry, and this entry is 1/2 times the probability of A at that point and the probability of B at that point. And we know from the second table here, as an example, we just found that the probability of U equaling 0 is equal to 2/3, and the probability of V equaling 0 is equal to 1/2. So essentially we are said two things, this one and this one times this one. So this part is this one, and these two parts are this one and this one. So all we need to do is multiply them and see if this holds true or not. So the probability of U equaling 0 and V equaling 0 is 1/2. So 1/2, essentially this is what we are saying here, is equal or not, we want to find that, to 2/3 times 1/2. And we can see clearly here that this is not the case. So the answer to this question is no. U and V are not independent. And the reason why is that 1/2 is not equal to 2/6.